Hi and welcome. We are going to dilate a function by a factor of 4. Now the function we're talking about is an absolute function. It's y equals the absolute value of x. We're going to dilate that vertically by the factor of 4. Now what is 4? It's a vertical dilation, and with vertical dilations you take it, it's a constant that goes in front of the function like k right here, k of x, and if that function k or that constant k is greater than 1, then you get something called a stretch, and it stretches vertically. In other words, whatever y value you get on the parent function, this stretches further up or down depending on the type of stretch that you're going to have. Now, if, however, that your k value, your vertical scale factor, is between 0 and 1, for example, a fraction, then it's going to be compressed. Now, does this vertical scale factor k, does that change the shape of the actual function or the graph? Yes, it does. It changes the shape. It makes it taller. It makes it more compressed. It does change it, but in a vertical way. So let's have a look at this particular example. We got y equals the absolute value of x, and the vertical dilation factor is 4. So clearly we can write down k equals 4. That's this guy right there. And we take the 4 and we put it in front of the function. That's our function there. So now it's going to be y is equal to 4, I'll put it in red, 4 absolute value of x. That's our new function right now, 4 times the absolute value of x. Now, at the moment, we've got a sketch of it right here, and it's just the parent function, y equals the absolute value of x. We haven't applied the dilation factor of 4 yet. We're about to. Now, in order for us to do that, we're going to draw a little small table of values and put some values in there, some points, and join the dots and see what it actually looks like. But because we know that it's a dilation, vertical dilation of 4, and 4 is greater than 1, we know that it's vertically going to be stretched up that way, towards the y-axis and away from the horizontal axis. And the shape will change. We have this shape right now. It will change. It's probably going to go, if we're going to stretch it, it's going to go narrower and taller. So let's have a look what it's going to look like once we put a table of values. So I'm going to compare this one with that one so we can see both of them. So we'll have an x value, and then the absolute value of x, and then 4 times the absolute value of x. Okay, let's put in some values in here. So first off, let's just have 1, 2, 3, maybe 4. 1, 2, 3, 4. Now, 1 substituted into the absolute value of x in the parent function is going to be 1. 2 into that will be 2. 3 into that will be 3. 4 into that will be 4. It's identical. It's x for y, x for y, x for y. It matches. That's our drawing right now. So when x equals 1, it goes up to y1. 2, 2, 3, 3, 4, 4, 5, 5, and so forth. Now, let's look at 4 times the absolute value of x. All we have to do now is multiply. We've got to multiply the x value by 4. So 1 times 4 is 4. And then 4 times 2 is 8. 3 times 4 is 12. And 4 times 4 is 16. So the y values are getting taller and taller. So let's have a look at the first value. Let's go for 1, 4. 1 and then up 4 will be right here. So if you notice, originally the parent function is 1, 1. Now it's 1, 4. It is 4 times taller already at that particular point. So let's go 2, 8. Across 2 on the x and up 8. Right there. Okay, do we have any other values that fit? 3, 12 or 12 is not going to fit. So we can mirror this on the opposite direction. So if we go 1 to the right, up 4, we can go 1 to the left, up 4. It'll be identical because the absolute value of a negative number becomes positive. So we won't get anything below the x-axis. So let's go -1, 4, and then we had positive 2, 8. So negative 2 will be 8 right there. So if we just join the dots here, we're going to have this kind of a thing happening. It's not very straight, but imagine it being straight. And there we go. That looks a lot taller, and that's the new function with the new dilation factor of 4, meaning that it's 4 times taller. You can see that the shape has changed of the original parent function, and now it's called y is equal to 4 absolute value of x. So the new function, the dilated one, y equals 4 absolute value of x.